Okay, good afternoon, everyone. Welcome to our Terrascope webinar about the use of Earth observation data for air quality monitoring. My name is Evelien, and today we have the pleasure to welcome Isabelle De Smedt from the Belgian Institute for Space Aeronomy. Isabelle is a master and PhD in applied sciences. She made her PhD on the retrieval of formaldehyde columns from satellite measurements at BIRA, where she has been working since 2001. She is responsible for the TROPOMI formaldehyde operational product, and her main interest is in remote sensing for air quality monitoring from space. Please note that you can ask questions via the Q&A feature in the toolbar. You can all upvote questions if you wish to receive similar information. If you have any technical issues, you can contact us via the chat. Enjoy the webinar, and Isabelle, the floor is yours.
Okay, thank you. So thank you everyone for attending this webinar. So I will talk today about additional Sentinel-5P data product available in the Terrascope platform. So first, some words about Terrascope. So Terrascope is the Belgian collaborative ground segment for the Copernicus Sentinel missions. Not only the atmosphere, but also land and marine Sentinel. And the platform provides easy access to satellite data, but also the product derived from satellite data. And it comes with a nice data viewer and geospatial web service, and cloud processing capacity as well, such as Jupyter Notebooks, for example. So the access is open and free for everyone, scientists, public authority, industry, citizen. And this platform is funded by BELSPO, and we know that it will be funded for at least 5 more years, which is a very good news. So yes, this is a screenshot, quickly a screenshot of the data viewer on which you can find the Sentinel, all the Sentinel data, but also more data, such as, for example, the ProbaV vegetation monitoring data and other external information. So now about Copernicus, the Copernicus program and its Sentinel. So Copernicus is the European Union program for the Earth observation. And there are 6 thematic areas for the Earth observation. And one of them is the atmosphere. Europe has launched a set of satellite instruments, so called the Sentinels. And one of these Sentinel is Sentinel-5 precursor, so S5P. And on S5P, so S5P is the first Sentinel dedicated to the atmosphere observation. It has been launched in October 2017, so it has been almost 6 years now. And TROPOMI is the only instrument on board the S5P satellite. TROPOMI, so it's a multispectral spectrometer that offers a daily global coverage of the Earth with a unique spatial resolution for this kind of instrument, so that it can measure air pollution and its sources at suburban scale. The main operational product for TROPOMI are the ozone total column, but also profile and tropospheric column, nitrogen dioxide, sulfur dioxide, formaldehyde, all retrieved in the UV visible spectral range. Then you have cloud and aerosols retrieved in the near infrared. And then carbon monoxide and methane are retrieved in the shortwave infrared. And this is also a great advantage of TROPOMI to offer such a large range of wavelength, and therefore different satellite product, and a good number of molecules observed simultaneously. So now I come to the topic of today. So since 2019, BIRA and VITO have been collaborating to provide graded TROPOMI data in the Terrascope data viewer. you will see that we provide daily, monthly, and yearly average data, so graded data, and that we have now 6 years of tropomi observation. In 2021, we released NO2, so nitrogen dioxide and carbon monoxide product. And now, since June 2023, so last year, 2 additional products have been added, formaldehyde and methane. Some more words about these 2 new products. So formaldehyde observations are used to support air quality and climate studies. Formaldehyde is produced as an intermediate gas in most chemical formation chain that finally produce CO and CO2. So it's a proxy for the presence of NMVOC emissions that are involved in the production of tropospheric ozone, so important for both air quality and climate change. The main source of NMVOC are the biogenic emission from vegetation, so over forest, mainly biomass burning, and also human activities over industrial and areas and big cities. So the detection of formaldehyde is highly relevant in air quality and climate studies. And then methane, so monitoring the atmospheric increase of methane, actually. This was news that was published on Terrascope. Methane is a greenhouse gas that is emitted from both natural and anthropogenic sources. Its capacity is about 30 times more efficient than CO2, but its atmospheric lifetime is only about 10 years, so much shorter compared to CO2. And so we can really act on methane emission to have a better control, or try to have a better control on climate change. And since over the last few years, an increase of the atmospheric methane growth rate has been observed, and therefore the monitoring the methane trends are really, with tropomi, is really essential for climate change studies. So now I come back to the Terrascope viewer, and I summarize this first introduction. So we have now 4 tropomi products available in the viewer. So with daily, monthly, and yearly data for each of them at different spatial resolution to get the most information out of the observation. So for example, methane, CO and methane are provided at the spatial resolution of 0.05 degrees in latitude longitude, while NO2 is provided with a finer resolution because the quality of the product allows it, and because the spatial resolution and distribution of NO2 is much finer, so we can observe that in the viewer. And then for formaldehyde, we use a coarser resolution for the daily maps in order to reduce the noise on the observation. And then for monthly and yearly observation, then we use the same fine spatial grid as CO and methane. Okay, so let's move on with some example of formaldehyde product and application. So here I show a first comparison of the global map of formaldehyde in 2019. And using the compare tool of the viewer, we can switch between 2019 and 2023 and try to detect some change and differences. And so, for example, you can observe significantly larger column over Canada and also South America in 2023 compared to 2019. While in China, the concentration appears to be a bit lower. While in the rest of the world does not show large differences. The interannual variability of formaldehyde is mainly related to fire event and to temperature variation between year to year. while the trends, the longer time trend can be related then to anthropogenic emission changes. Yes, and so with so I wanted to show you the one application which is to use the Terrascope notebooks, Jupyter notebook, to create different maps. So this is quite easy, and it's a nice illustration of the application that anyone can try. It's quite easy, and you can get a very good support from the Vito team. So that's what I did last week. And this allows to quickly create different maps, for example, and plot of time series without having to download the data, which is really nice. So let's see a quick example. So with the Jupyter notebook, we can connect to the OpenEO Vito server, and then get the Terrascope collection. Here, for example, the list of TROPOMI S5P collection available, and create some different maps. So here I made a map, a global map of the difference between the year 2023 and 2019 for formaldehyde. So you can see this large increase in Canada, smaller increase over South America, also a bit of increase in Africa, and then the lower column in the Siberia forests. That's because the fire were larger in the year 19 in this case. Another increase over Eastern China, and also over Australia, but this is also because the fire were really strong in 19. But let's focus also on the fire in Canada last year. So that's the first use case that we wanted to show. So we know that wildfires are natural phenomena, but they have shown to be particularly intense around the world in the most recent years, with a large impact on the air quality and the environment, of course. And so in 2023, we had very intense wildfire in Canada, but not only. And so here I'm showing an animation that was created by Bira and Vito. So those are formaldehyde daily observation that you can see here. Each day is running quite fast between June and August 23. So the year 23 was really exceptionally warm and dry in this part of the world, and leading to the worst fires in Canadian history. And the emission of hydrocarbon, or NMVOCs, from the fire were so important that we observe very long-range transport of formaldehyde column and plumes. So you can see the plumes can go very far away from the source in Canada. Despite the fact that the lifetime of formaldehyde is only a few hours, but the quantity of the emitted pollutant was so large, and the altitude of the plume also was so high that secondary production could happen thousands of kilometers away from the fire source, with, of course, an important and bad impact on air quality over Canada and up to the United States, even in the US. So this was, for example, the case in early days of June. Maybe you remember this episode in June last year, when the sky in New York became completely orange during a few days. People had to wear masks to protect their respiratory system. And so this was due really to transport of pollutant and aerosol from the Canada fire up to the eastern coast of US. You can follow this on the Terrascope viewer. You can look at formaldehyde and CO data day by day and follow the plumes and see that they reach the West Coast, the US eastern coast quite quickly. And so this is a really important advantage of TROPOMI and of the Terrascope viewer, is to be able to observe several pollutants at the same time And this brings a lot of information about the different sources and the chemistry going on during these events, this kind of events. This is another example of the same fire, but a few weeks later. So this was in August, yeah, another severe fire happened near a popular lake in Canada. And here again, you can see a simultaneous observation of very large formaldehyde and CO column on this day. So yes, what the advantage is that the lifetime of formaldehyde and CO are quite different. The lifetime of CO is about several months, while formaldehyde here, the lifetime is only a few hours. So CO is more used to follow the plumes, while formaldehyde is generally used to detect localized sources. But in this case, the emissions were so strong that we could also follow the plume of formaldehyde as well as CO, quite a long distance from the sources. Okay, another example is of observing simultaneous emission of pollutant here to monitor air quality. Happened last winter time in Pakistan and India. So this also had the news. So yeah, last winter time, it was not due to a wildfire as in Canada, but rather to industrial emission and agricultural fire. So in early November, the Pakistan province, the Punjab, was trapped in a cloud of aerosol and pollutant, and the country stayed an emergency, and all public places were closed. In New Delhi, the schools were closed, and the construction and industrial activity had to stop. Later in November, yes, face masks were made mandatory in Lahore. And as I said here, it's not wildfire, but it's rather poor air quality due to industrial emissions and agricultural waste burning in this region. And also it was winter time, so burning of solid fuel for cooking and eating adds to the air pollution, and also the meteorological condition and the geography of this region play a role, since the Himalaya mountains act as a barrier and block the pollution in this area, creating an accumulation of air pollution. So again, here are some different observations of the different gases that you can have access in Terrascope. So for example, here I took 1 month of formaldehyde data in November 23, and you can see, despite it's not summertime, so there are almost no biogenic emission, but the concentration and the level of formaldehyde are quite very high actually. Then I show also 1 day of CO with very large emission in end of October in Pakistan. And then a map of NO2, also 1 day in December of NO2 emission. So you can see that the NO2 emissions are much more localized than the hydrocarbon one, but they can be really strong, and especially in winter time. And so I play again a little bit in the Terrascope notebook. So here we defined two regions in Pakistan and New Delhi, and try to get time series of these molecules actually, so that's the result. So here I plot Delhi observation for each gases in these two regions, so formaldehyde, CO, and NO2 over the full year 2023. So you can see, for example, in the formaldehyde and CO column, the strong increase in November, around November. over New Delhi, and this is followed by another increase, a bit lower in intensity, but around Lahore. So it means that there was some transport from New Delhi to Lahore, especially of CO. This is less the case in formaldehyde. And you can also see that NO2 shows quite a different behavior than formaldehyde and CO, with a longer period of elevated concentration over New Delhi and almost no significant increase over Lahore. So this kind of differences are interesting. They are due to different type of sources for each pollutant and also to different lifetime of the molecule and different chemistry. So this is really an advantage to be able to observe them at the same time. Yeah, so now I switch to methane, the methane product, and I also start by comparing the year 2019 and 23. So here you see, this is quite obvious, the increase, which is global, sorry. Sorry, kids coming back from school. So you can observe the increase between 19 and 23, and which is global because remember that the lifetime of methane is about 10 years, so which is much longer than the air quality molecule. So that explains the global and constant increase of the methane concentration. But however, some regions pop up with larger emission, so in particular Central Africa here. So here again, I made a different map of methane in relative units, so in percent. And you see that the global increase is about, let's say, 3% globally, but over Central Africa, the increase is almost twice larger here and also here in South Sudan. So that's a concern for scientists. So we know that methane concentration are increasing. They have been increasing since the industrial years, but this increase has been unexpectedly quicker in the recent years. So there is an acceleration of the increase. And this is the subject of many studies and concern of the scientific community. So the growth rate of methane has been accelerating recently, and those recent changes are partly attributed, not only, but partly to a strong increase of the wetland emission in the tropics, and particularly in South Sudan and the White Nile Basin. So yeah, we can again look at the yearly map of methane for every year of TROPOMI observation. So with a particular focus over Central Africa, 20, 21, 22, 23, and you can really see that something is happening in this region. So again, I use the notebook and I define two regions this time. So one in this region, which is the White Nile basin, where you can see large concentration of methane appearing, and then another region where the formaldehyde and CO column shows also quite large concentration. This is more a national park with more forest and woodlands, but also wetlands. So that I defined these two regions and plotted at the same time the formaldehyde and CO column, NO2 and methane. So first you can see that the methane concentration are clearly increasing, but more in this first region, so around the White Nile area. And this is caused by flooding in the recent years that increase the emission from wetland. It's also increasing in the other region, while for formaldehyde and CO, the increase is clear in the other regions, more around this national park. So probably more related to fire and increase of temperature with the years. While NO2 is more stable with years, does not show this kind of increase, except for an anomaly in 2019. Well, I must say I did not find the reason for this large NO2 column this year. So if you have an idea, I would be interested. But there is no clear increase. And so there is actually much more that we could do with Terrascope. So for example, here I quickly added to the observation the NDVI product from ProbaV, which ends in 2021. But you can we can start to look at the correlation between all satellite observation. For example, here you can see a clear correlation between the seasonal variation of NDVI, so vegetation activity, and formaldehyde and CO column. But that was really a quick test, but we could do much more with this kind of cross-platform observation as well. So that was it for formaldehyde and methane. So I have, I think, a few minutes more, and I will present the product that are coming very soon this year, I think. I heard even before summer. So there is the TROPOMI SO2 product, which is coming. So it's not the operational product, it's an improved product from the COBRA algorithm. I will show one example. Then next on the list is a regional NO2 product for Europe. And the last one is surface NO2 concentration, also derived from TROPOMI measurement, but using machine learning and more data information. So let's see. So SO2, the source of SO2 are mainly anthropogenic, but also from volcanic activity. And so the impact range from short-term pollution to climate forcing effect on a global scale. And so the operational product is derived with a classic DOAS retrieval algorithm, but this suffer from noise and bias for low SO2 amount. So now with this new published COBRA algorithm, this is very much improved, and the algorithm allows for the detection of emission SO2 sources much weaker than before. So we can really work on source inventory for SO2s and SO2 and emission monitoring. So this is coming very soon. Here are some examples. For NO2, so the operational product is using as a priori profile the global the global TM5 model. And so KNMI has developed an improved tropospheric product for the European domain, which is using the CAMS regional model as a priori profile. And this allows to improve the spatial resolution of the product for Europe. So here you see the ratio between the two different products with an improved spatial resolution around the cities or along the shipping lanes, for example. So the product will be provided on the same spatial grid as the operational product, but we will be able to see an improvement in the spatial resolution. So also coming soon. And then last but not least, so the NO2 surface concentration over Belgium, and I think a bit larger than Belgium too. So because we know that the public is interested in the NO2 surface concentration and not into the total NO2 column or tropospheric column, but this is not a quantity that the satellite instrument can retrieve. But on the other hand, the satellite offers daily global coverage. So here the ISD is to combine surface concentration, sparse surface concentration measurement and global satellite data of total column, tropospheric column of NO2, and using machine learning, try to derive a global or regional product providing surface concentration of NO2. So the main data that are used by the model are the TROPOMI NO2 observation and also the Irselin Grant NO2 measurement. And then meteorological dataset, Belgian emission, the population in Belgium, the elevation, and other external data. So this work has been published and will also appear soon in the viewer. And with that, I think I'll stop here and I'm happy to answer your question.
Thank you, Isabelle, for the presentation and the many examples. We move to the Q&A, which will be moderated by Jürgen.
Thank you, Isabelle. It was very clear and very inspiring. I already have one question in the Q&A, and I encourage all other participants to post their questions there. Someone is asking about references or resources about using formaldehyde as a proxy for NMVOCs. Do you have that kind of information?
There are plenty of papers, yes. You can look for my paper, for example, but also, yeah, a lot of paper from modeling groups. So using formaldehyde observation to constrain their NMVOC emission by inverse modeling technique. I can cite the papers of Jenny Stavrakou from our group, for example, Stavrakou et al., if you want to, or I could share more references, but there are plenty.
So if people look for your name and combine that with formaldehyde and NMVOCs, they'll get...
Yeah, I think they will find references, yeah.
Okay. And if not, they can always ask more information via info@terrascope.be, and we will relay that to Isabelle, and then you'll get an answer very soon. There's another question coming in. What work is being done to reduce the noise in the TROPOMI formaldehyde measurements?
Yeah, well, this is a good question and not easy question. So the noise in the UV observation is always a bit larger than in the visible one. So UV is used to retrieve formaldehyde, NO2 is retrieved in the visible. The signal to noise ratio of the retrieval is really related to the signal to noise ratio of the instrument. So we are a bit dependent on the quality of the instrument, and TROPOMI is really good for this. But still, we have more noise than in the visible, and also because the optical absorption of formaldehyde is lower. So it's difficult to improve. We can average the data. That's the main technique for the moment. And then there are other techniques like Cobra or PCA algorithm, but they are more difficult to apply to formaldehyde because formaldehyde is everywhere. It's a global molecule, and it's difficult to find areas with no formaldehyde to serve as reference. So it's more complicated, but some people are working on it. Yeah.
But so the main way to reduce the noise is to work with monthly averages or yearly averages, where you can also improve the spatial resolution then.
Yeah. Because it's really noise, so if you average the data, it's reduced. Yeah.
While other people are posing questions, I will ask one myself. It's very interesting to see that you can derive the ground NO2 concentration from space. Would that same approach work for the other gases as well?
So you cannot do you need machine learning and you need external information like surface concentration. So yes, in principle, it's also applicable to other molecules, like, for example, ozone. That would be really nice. And I know that So Wenfu, who is developing the NO2 surface colonies, is willing to try for surface ozone. There was one paper about formaldehyde applying the same technique. So it's in principle possible, but you need enough external information and measurement.
Yeah. Because the view of New Delhi area down to Dhaka is very concerning. As formaldehyde is very reactive and causes cancer. If I'm right.
Yeah. But so yeah, the difficulty with formaldehyde is that there is only one source. It's a bit different from NO2, so you also have to combine different type of source from the natural and anthropogenic emissions. So that's you need also a model to separate the source.
Okay, I have a raised hand. So Monica, if you would simply unmute yourself and ask the question. You're still muted. If you unmute yourself.
I'm sorry, the questions that have been asked are already very informative for me. I raised my hand without even noticing while I was seeing the presentation. I'm so sorry for causing.
Oh, no. But if you have a question, can't you? There's nothing that you want to ask Isabelle while you're here.
I am new to the subject, and it was already very informative for me. And the extra question that were asked were actually super nice for me to get more insight into this.
Mm-hmm.
So for now, I think I'm fine. It was very clear, everything. Yeah.
Thank you. There's no more questions coming in. Maybe I should warn people that if they want to use the Jupyter notebooks, it is very simple. You simply have to register on Terrascope. And as soon as you're registered, the notebooks are available to you. If you have any trouble getting these time series or difference images to work, contact us. We have a sample ready for you to use. When you start using it, you will see that it's still using Python 3.6, but we're working on upgrading that to a more recent version so that you don't have to worry about deprecated software. And if there is no other question, this is a final call. There doesn't seem to be any. Then I will give the word back to Evelyn.
Okay, that brings us to the end of the webinar. Thank you, Isabelle and Jürgen. And just to mention, indeed, we have some new webinars coming up in May and June about the integration with the Copernicus data space ecosystem and OpenEO. Very interesting to join for a wide public, and one in June on the use of CropSat to overcome cloud cover limitations. More information is available on the website and you can register. So thank you all for joining and hope to see you at one of our next webinars.
Thank you.
Thank you. Bye-bye.
Goodbye.